Hi everyone, I'm Tato Tebe. I'm a BH Tech Industrial Engineering student. So I'm here to share my understanding of industrial design projects, which is a module that we're doing this year concerning work integrated learning. So I'm here to ensure that we all pass and we do our best and we excel in our projects by giving you an understanding of what industrial design project is about. So as we all know, we have EXA, which is the Engineering Council of South Africa, which ensures and maintains the quality and standards of engineers everywhere in South Africa. So EXA has graduate attributes that we must all adhere to. And in this module, we have 3 of those attributes that we need to adhere to. And I'm going to share some of those attributes with you guys. Like I mentioned in our study guide for IGP, we have those graduate attributes. In this module, we focus on graduate attribute number 2, 3, and 6, of which 2 is application of scientific and engineering knowledge. Number 3, you can just call them GAs. GA3 is engineering design, GA6, professional and technical communication. Now, this only means that in your design project, for whichever company that you're going to work at, you need to adhere to these. Your design for your product or a process must adhere to these graduate attributes that you see here. I'm going to share a bit on what they entail. So like I mentioned, your graduate attributes include application of scientific and engineering knowledge, meaning you're going to be apply the knowledge that you consumed in class, which is engineering and science related, to your projects that you will be choosing or given at the workplace of your choice for this module. So you have engineering design as well, meaning in your design, because you have an option of product and process, in your design, it must be engineering related for you to apply an engineering related solution as an industrial engineer. That's what we need to be focusing on. And the last one is graduate attribute number 6, which is professional and technical communication. We all know that we did communications in first year, and it's very vital that you apply yourself here, because at your workplace, the company that you're going to be at, all these graduate attributes you're going to be evaluated on. And if you cannot adhere to these graduate attributes, it means you will not graduate, because this is what EXA expects from all of us. Thank you.
Hi, my name is Isita Mahate, fellow third year industrial engineering student. Throughout this presentation, we've been explaining the IDP project and benefits and what you're supposed to fundamentally grab from this project. I want to talk about the layout of a facility or manufacturing place. This layout, as you can see, it's in 3D, so it was drawn. These are tools you can use, such as CAD or SolidWorks. These softwares that we've been covering from first year, second year, they are at your disposal now to be able to explain the issue that you found and how it can be improved. So what happens here at this facility, that you can see, that's an office. This is inbound receiving, where deliveries are made. This is out of bound, where they take off. This is the picking, and this is storage. The way it looks is very simple, but it is how you'll have to illustrate how the flow of the layout, the flow of work is efficient, it saves money, and it's not time consuming. As I was saying, the facility layout is not just a random placing of objects. As you can see in this diagram, this is delivered. These are the trucks that collect, this is loading, and this is a conveyor, and these are the products that are within the facility. One thing you must understand is that as an industrial engineer, you're constantly focused on improving the efficiency of a working system. So as a result, if for some reason you were to position, let's say, the trucks on this side and the main road on that side, this is this is a delay that is avoidable. You are doing this in IWS first year. They teach you about avoidable delays and unavoidable delays. These are the things you're aiming at, because once a delay is avoidable, it will cost the company money. And when we're working at something that's really large scale, it can be into the 100 millions or even billions, depending on how much time it wastes and what is actually what the delay actually is. So what you're supposed to be taking from this presentation is that these little things that you've been learning since your first year, second year, and third year have been building blocks that you'll be using to apply in this IDP project, because this thing, this layout, although on facial craft it looks simple, it's the fundamental basis in which companies actually grow and depend on. As an industrial engineer, you're not just there to say, no, this is inefficient. You're there to look at it, absorb it, understand it, and develop a better system that can work. Each and every single facility layout has a specific and long story behind it, which allowed it to be built in which the workingness of the system is very efficient. Thank you.
Okay. All right. My name is Usiso Mahlangu, and I'm a BH Tech graduate, currently studying B Honors in Industrial Engineering. So I will cover the outcomes of industrial design projects. So the outcomes of industrial design projects, part of it is that the students should be able to design. It says industrial design project. So the emphasis on design for the project is the students should be able to design layouts, they should be able to design process flows, they should be able to design delivery schedules, and then they should also be able to design bill of materials, among other things. So this does not just limit the scope of industrial design projects, but it just gives an idea or industrial engineering techniques that we can use to ensure that we meet the outcomes of industrial design projects. So this is just a portion of my assignment, and what I want to put emphasis on is the cost analysis of what you have to design. So whatever that you will implement at wherever workstation where you will work, you have to make sure that it does not hit the budget of the company. So the optimizations, they will obviously minimize the lead time, they will obviously, they have to obviously increase the revenue of the business. So added to that is that please don't take chances. This assignment has, or this project rather, has to be signed off wherever that you go and do your project at. So as you can see there, this is an industrial design project sign-off report where your supervisor at your workplace has to sign it off and actually give comments, evaluation criteria on how you are of value to the company. So as we slide up, you can see there, as company details, you have to put the company name where you did this and then everything. This detail is on your study guide. If you go to the 32nd and from 31 to 33rd of your study guide, you will find these things there. The last part is just the rubric, so you have to ensure that your assessment adheres to the rubrics there, as my fellow BH student said, Tatotele. So as you can see, you can just slide down to the 33rd page on your study guide, and then you will definitely find it. So take your time, research as much as you can, and ensure that you submit a worthy project so that you can get good marks. Thank you.
So after they check if their specifications are correct, then they go into the cutting the fabric. And then they go to the check if the measurements are correct or not. Then they start sewing, inspect, then they check the quality. So when you are analyzing their process layout, right, you can just look into maybe one department, the quality department, and see where they are wasting their time. Then you develop a process for that department to ensure that it improves the company, and also like it will improve the revenue of the company. Yeah, that's it.
Hi guys, my name is Matlabung Katlele and I'm doing my third year in industrial engineering. So today I'll be focusing on the bill of materials. So basically the purpose of the bill of materials is to help organizations plan purchase of the materials, estimate cost, control inventory, and to minimize production delays and waste. So today we'll be using a bicycle as our examples. As you can see over here, they disassembled the bicycle, and then we have the frame, and you can also break down the frame into a fork, a crank cam, and a pedal. And we also have the handlebar, and we have the wheels, and we have the seat. And you can also disassemble the wheel into a rim and a tire. And we can also use the Giga car as our example, as we all know that we did the Giga car in our first year. So these are the materials that they use. So they used 4 wheels, the doors, and the bumpers and the seat. So yeah, this will also help you know how many materials that you need to produce your product, and so that you can know what to do and what not to do. Thank you.
Hello guys, this is Emmanuel Mamba, a third year student at the Tshwane University of Technology doing industrial engineering, and a student who will be visiting a company for the IDP project. Here I'm going to just brief you, and here is a brief of what is expected from a student when a student gets into the company. And this is what is expected when you approach a company. A company expects students to identify all the bottlenecks within the station or within the organization, come up with strategies to increase efficiency, to increase flexibility, for more profitable business practices, for more increased customer services, for more quality, and to increase productivity. Here are some of the tips of what is expected from a student when a student has identified that particular bottleneck station. A student must come up with a delivery timeline with schedules and resources. Get those parts and break them down into small pieces, and therefore come up with the phase title, schedule them, come up with all the budgets, all the resources needed to produce that particular product, come up with risks, name them down, write down the issues and the comments of all the workers around the workstation. What are the benefits of a delivery schedule? A student knows that the benefits of a delivery schedule is to lower delivery costs, to come up with more reliable delivery performances, and to come up with better utilization of delivery resources. There are some types of software that can be used to produce a delivery schedule. What software can managers use? There's a software called Delivery Management Software, also known as a DMS, and a Microsoft Excel. And there are some other softwares that drivers can use, such as a Road for Me, On Time 360 Degrees, a Go Move, Dispatch Sciences, and so forth. And here's an example of a delivery schedule. A delivery schedule must have all the specifications of who will be delivering the product, from where and to where, the order number, the drop-off location, the recipient phone number, the time of delivery, and proof of delivery obtained. All these are the crucial points that the student must look into. Within the bottleneck stations, there are other resources or schedules that a student can look into, like a student designing a capacity schedule, a resource schedule, and a service schedule. All these, a student can simply go and look into them when they approach a company. I hope and wish you all the best in your workstations that you'll be working into. Remember guys, keep it safe. Thank you.
Greetings, my name is Jameson Shakwane, and I'm here to do the conclusion of this presentation. As my team has explained a number of things on what to expect in this project and what also is expected of the learners, I'll be focusing on some of the softwares that you can use, or rather applications that you can use as an industrial design project student to carry out this project, and also the do's and the don'ts of the project. Now we have a number of softwares that are available to us, and we have used them before. These are not foreign softwares. So here I have 3 of them, and one of the softwares is Simio. Simio is really a good software when you want to simulate, or rather design, a layout of a facility. So you can use it to show your before and after layout when you have applied improvements wherever you'd be allocated if there's a need for it. So it is really a good program that you can use to design facility layouts and to show the simulation of how things can be done during production, because it has so many things that you can use them to your advantage. Another software which is not listed here, which you can look into, especially if you would want to do something that is related to layout design, it is Visio. It is also a good software when it comes to doing 2D and 3D layouts. Another software which you can look at is SolidWorks. SolidWorks is really a good and efficient software if you'd want to design products such as jigs and fixtures. These are things that we look into as industrial engineers, because jigs and fixtures, they actually improve the manufacturing process of certain products. So I would advise that wherever you are assigned, especially if it is a production facility, look where there's a need for a jig or a fixture, and then you can use SolidWorks to design such products. And the last one is Excel. With Excel, you can use it for graphical representations, especially if you want to show how certain of the data looks on paper before you apply your process improvements and how it looks afterwards. This can help you show how the production rate has decreased using graphical methods. And also it can also show you how the production rates have also improved as you applied the solutions. And these are some of the things that you are expected not to do or not to consider doing. Figure 1 shows an electrical transformer. We are industrial engineers, we are not electrical engineers, so we know very little about electrical transformer. So try to stay away from such products, because there's a lot that goes into it. It's not just about the structure of it, but it's about how this component or other product really functions. Also, when you look at figure 2, we have a manufacturing robot. Manufacturing robots, they require a lot of programming skills, and people who normally deal with such are the mechatronics guys, and we are not there. So an average industrial engineer is not really skilled in programming of robots, but rather in how to apply them. So it will be advisable to stay away from robotic products and things like that, so that you can make your life a lot easier. And the last one would be a car engine or gearbox. So this is really the field of mechanical engineers, and not even all mechanical engineers have the ability to redesign and design a gearbox or a car engine, unless, of course, you major in designing parts for the automotive industry. So it will be advisable to stay away from such products. And these are some of the departments where you can be allocated into. It's the quality department. You can apply the skills that are taught to us in QMS. They'll be really helpful if you're in the quality department. Is also supply chain, which where now OPR and things like simulation design come in. And you also have the production department. That is where you can apply the skills of production engineering, production automation, so that you can find a problem and implement a solution to a problem. And this is the end of this presentation. Thank you for the team for participating, and also I hope this will be helpful to you guys as how you should go about doing your IDP project. Thank you.
Hello, it's Ryan Tierney here from Satan Matters, and would like to show you a recent improvement we done in our welding area.
So the task is actually quite simple, but there's a lot of non-value added activity in the process. Okay, Paddy, so this is the before video.
Yeah.
So what are we trying to make here?
We're just trying to make these nuts and bolts here for the jigs. So there's 14 goes in each jig round, and we have to stand here and put these on.
So it's very tedious.
Yeah, it's very tedious, and it takes up a lot of time.
So this is how we used to do it. We had to put every single nut on by hand. So if we even watch the detail, we'll count the number of turns, because every single turn is waste. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 turns. And how many nuts at a time?
We have like 240 nuts a day just for all our chairs.
240 nuts a day
Yeah.
by 10 turns.
Yeah.
Okay. So there was also the possibility for inconsistencies. Some nuts could have been threaded more than others depending on who was carrying out the task. So Paddy worked with our design team for a few days and come up with this amazing jig to make this process so much easier. Even the attention to detail on the angle of the box, so it's easy to reach in and out of. The whole trolley is flexible, it's on casters. We've got crumb trails leading us back to where to restock the part from when it goes low. There's visual controls in the front of all the bins. This improvement really makes work so easy and makes this job a pleasure to carry out. The goal is to put the nut on the bolt at the correct level. So let's see how the after video has improved this process. So the first step now is to lift the bolt and set it into the located hole on the metal plate which holds the bolt in place. So the next step is to put the nut on the bolts, and both hands are now free to carry out the task. So as you can see, it's a really simple improvement. We're using a drill and we're saving 2,400 manual turns per day. So I noticed, Paddy, that the standard is the exact same on every single nut because of the depth of the bit on the drill. So the standard and the quality has improved a lot. So I think the key message in this video is that this improvement frees up Paddy to be more creative. Paddy no longer has to struggle with putting the nuts on the bolts, ensuring they're at the correct level and so on. So Paddy's mind is now more free for creative thinking of the next improvement, thinking of the next design, thinking of the next layout for his area. It's freeing up our mind to be more creative. This is the power of continuous improvement.